This training is provided by SafeShield. We're a professional training provider that specializes in cybersecurity, compliance, risk management, and AI governance. Our goal is to give professionals the knowledge and skills required to advance their careers and get ahead of the competition. This free course is part of that goal. We want to make trusted, high-quality education accessible, and to support the development of responsible practices in new and emerging fields such as AI governance. Welcome to this course on the principles of AI governance. This course is a continuation of our learning journey and follows on from our AI Governance Foundations course. In our AI Governance Foundations course, we laid the groundwork by introducing the key concepts, risks, and motivations behind AI governance. Here we'll build on that by moving from the why of AI governance and into the how. We'll cover how governance is structured and applied through universal principles and international frameworks. During this course, we have three main goals. First is to help deepen your understanding of why AI governance is essential for organizations that adopt or develop AI solutions. Second, to examine the core principles that guide responsible AI in the real world. We'll cover safety, accountability, transparency, and fairness, along with privacy, human oversight, sustainability, and the continuous monitoring of AI systems. Finally, we'll connect these principles with global frameworks including ISO/IEC 42001, the NIST AI Risk Management Framework, the OECD AI Principles, and the European Union Artificial Intelligence Act. We'll be focusing on how these principles take shape in practice. You'll see how they are applied across industries, embedded in standards, and enforced through regulation. We'll also look at the opportunities and the challenges of applying governance in a real-world context. By the end of this course, you should feel confident in recognizing and explaining the principles of AI governance and have the knowledge to apply them as part of your professional career. In our first course, we described AI governance as a way to link an AI system's outcomes back to human choices and clear responsibilities. Let's build on that. AI is already woven into most major industries. When it works well, it saves time and improves decisions. When it doesn't, people feel it. Unfair rejections, privacy leaks, or automated decisions no one can explain. Governance keeps those risks in view from the start. It asks simple questions that shape everything that follows. What is this system for? Who is responsible for it? How will people stay involved? And what evidence will we keep that it's working as intended? Laws such as the EU AI Act expect you to show how risks are managed. That means having records, oversight, and a way to act when things drift. Most of all, governance matters because people matter. If those affected can understand what a system does, ask for a review, and trust that someone is accountable, adoption of that system is easier and outcomes are more fair. That's the frame for the rest of this course. We'll take the principles you already know: accountability, transparency, fairness, privacy, safety, oversight, sustainability, and monitoring, and show you how they show up in real-life scenarios. With that frame in mind, let's zoom out to the global picture these ideas exist within. Our Fundamentals course introduced the idea that AI governance is the result of a growing global consensus, rather than the product of a single country or organization. Here we'll take that a step further, looking beyond the what, and instead into how they converge, where they differ, and why it matters. This consensus can be seen in the shared values across different jurisdictions and their relevant standards and frameworks. While terminology might differ slightly, the themes of accountability, transparency, fairness, human rights, safety, and sustainability remain consistent. Let's quickly revisit the major standards and frameworks that are relevant to our learning. The OECD AI Principles, adopted by over 40 countries, focused on economic and social responsibility. The UNESCO Recommendation on the Ethics of AI, endorsed by nearly 200 countries. Unique in covering areas that are underrepresented in most tech-focused frameworks. The EU AI Act, the first on our list to be a legally binding regulation. It categorizes AI systems by risk level and enforces governance requirements appropriately. ISO 42001. The first of its kind, it provides a certifiable management system specifically for AI. The NIST AI Risk Management Framework, often referred to as the NIST AI RMF, This US-based framework focuses on putting responsible AI into practice. We'll cover these in more depth later, but keep them in mind. They set the stage for how we approach AI governance. Now that we've outlined the most important principles and players in global AI governance, we can begin to understand how they provide context for what we, as learners, should focus on. It helps us see how AI governance is evolving into a lasting part of how society manages technology. One that shapes both the rules that organizations must follow and the standards of trust that are being set by public demand. So, what does that actually look like in practice? To explore this, we're going to look at the principle of accountability and how it's central to AI governance. You may remember from our first course that accountability was introduced as a way of ensuring AI systems are not being treated as autonomous black boxes. It provides a reliable way to link AI's decision-making and outcomes to human choices and responsibility. Here we'll expand on that idea and look at how accountability is structured and demonstrated in a practical sense. Accountability begins with clarity, which means assigning clear roles. Who is responsible for managing data? Who oversees development? Who monitors performance once the system is in use? Without these roles, responsibility gets hard to pin down, and it becomes harder to address issues when they arise. That's why many frameworks put accountability front and center. For example, ISO 42001 doesn't just say that organizations should be accountable. It specifies how accountability should be embedded into policies and processes across the entire AI lifecycle. It requires organizations to define responsibilities at every stage, document decision-making, and make sure those decisions can be linked back to those responsible. Now, this doesn't just apply to technical teams and those who develop AI systems. Leadership also plays a major role, with oversight being a key part of accountability. Decision-makers are expected to ensure that AI use reflects the values of their organization whilst still meeting regulatory requirements, and without introducing unnecessary risk. This oversight should be both internal and external, with things like certification and audits playing a big role in demonstrating and maintaining accountability within the organization. It's important to remember that accountability isn't just for assigning blame when something goes wrong. It serves as an effective way to change internal culture to one where individuals and teams understand their obligations, have the authority to act responsibly, and know how to escalate problems if they need to. Providing practical tools helps to bring this culture to life. Audit logs, for example, create a traceable record of decisions, ensuring actions can be reviewed and justified. Impact assessments force teams to pause and consider the wider consequences of deploying AI before it goes live, and reporting frameworks make it possible to transparently communicate both successes and failures. Tools like these can be an invaluable way of putting accountability into practice and changing organizational culture for the better. The main takeaway here is that accountability builds trust. It shows that organizations are thinking about more than just profit or efficiency, and that AI systems are being managed responsibly, in line with ethical and social expectations. Now, we've looked at accountability and how it gives us the tools to trace who is responsible. Let's move on to transparency and explainability to help us understand how those responsibilities are carried out in practice. We've already touched on one of the greatest challenges in AI, the so-called black box, an AI system whose internal workings and decision-making are difficult to decipher and understand, even for its creators. Transparency and explainability help us to tackle the black box problem in a practical way. First, let's talk about transparency. Transparency is all about openness, and it starts with documentation. Everything should be recorded, from data sources to training methods and model limitations. This provides a clear record of how a system was built, while also communicating its scope and risks to those who use or oversee it. Transparency also involves communicating the intended purpose of an AI system and the potential risks it could encounter. Explainability, on the other hand, is all about interpretation. It makes AI decisions understandable in human terms so they can be questioned, corrected, and trusted. For simple models, this is relatively straightforward. But for more complex AI, we need to rely on techniques specifically designed to reveal how decisions are made. For example, Local Interpretable Model Agnostic Explanations, or LIME, builds a simplified, interpretable model around a single decision to highlight which factors shaped that outcome. Techniques like LIME can be hard to picture, so here's a simple way to think about it. Imagine the whole model as a city. Lime doesn't redraw the entire map. It zooms into one neighborhood and draws a small, easy-to-read map of just that area. It won't explain every street in the city, but it shows which turns mattered for this trip. You may also see SHAP mentioned in other resources, but we'll stay with Lime here to keep things simple. Governance frameworks also stress the importance of tailoring explanations to different audiences. Technical teams may require detailed metrics, while end users need plain language justifications. It can often be effective to adopt a layered approach to transparency. High-level summaries for the public, technical documentation for regulators, and detailed logs for auditors. Importantly, explainability must be designed into systems from the beginning and not shoehorned in at a later date. Together, transparency and explainability underpin both accountability and fairness. Now, we've seen how transparency and explainability open up the black box and make AI decisions more understandable. But even if we can see how an AI works, we still need to ask an important question. Is it fair? That brings us to our next principle: fairness and non-discrimination. Fairness in AI governance ensures that systems do not reinforce or amplify bias. As we learned in our first course, AI models reflect the data they are trained on. If that data contains inequalities or blind spots, the model may reproduce them in its decisions. Bias can enter at many stages, through unrepresentative datasets, flawed labeling, or even subtle design choices in the algorithm. For example, facial recognition systems have historically been less accurate for women and people of color because their training data was not diverse enough. In financial services, credit scoring models have, at times, unfairly disadvantaged minority groups. To avoid this, we must treat fairness as a continuous process that requires ongoing adjustment. Governance frameworks recommend bias assessments at every stage of the AI lifecycle: data collection, model training, deployment, and ongoing monitoring. These checks might involve testing models for disparate impacts, rebalancing datasets, or refining algorithms. We must also consider inclusivity in our pursuit of fairness. An AI system that works well for some groups but consistently excludes or misrepresents others cannot truly be called fair. For example, if a healthcare tool only reflects data from younger patients, it may not serve older populations effectively. This is why governance frameworks place emphasis on inclusivity alongside fairness. The EU AI Act makes this explicit by classifying discriminatory practices, such as systems that exclude or disadvantage people based on race, gender, age, disability, or socioeconomic status, as high risk or even unacceptable. Ultimately, fairness is about protecting human rights and ensuring equity. Just as accountability and transparency build trust, fairness ensures that AI systems contribute positively to society rather than perpetuating harm. We now need to turn our attention to another principle that protects individual rights: privacy and data protection. In our first course, we introduced the idea that AI relies heavily on data, and that with that reliance comes responsibility. Here we'll go deeper into how governance frameworks address this responsibility in practice. AI systems often need large amounts of personal or sensitive data to function well. Without proper safeguards, this creates serious risks. Mishandling of this data can result in breaking the law and undermining trust in AI technology. That's why governance frameworks consistently put privacy at the forefront. In line with good privacy practices, people should know what data is being collected, how it will be used, and whether they can correct or delete it. We should also only be collecting the data that is necessary. This is the principle of minimization. It's why a routine health checkup form might ask your medical history, but not your social media passwords. We only want to focus on the data that's most relevant to us. We can add another layer of data protection by employing technical safeguards. This includes methods like anonymization, pseudonymization, or encryption, all of which help to reduce the risk of exposing personal data. More advanced approaches like differential privacy even allow data to be used for training AI models while making it nearly impossible to trace information back to any one individual. Good governance means checking systems before problems occur. One common tool for this is the Data Protection Impact Assessment, or DPIA. Think of it like a pre-flight check before an AI system goes live. A DPIA asks questions like, what personal data will this system use? Could that information be misused or exposed? And if so, what safeguards need to be in place? By running this kind of assessment, risks can be spotted and reduced early, rather than being discovered after harm has already occurred. Fundamentally, privacy is rooted in human dignity. When people see that their data is being treated with care, they are more likely to trust the systems that use it. That trust, in turn, makes AI more effective because people will actually use and support it. Privacy and data protection are what make the use of AI sustainable and socially acceptable. The protection that privacy provides only matters if the systems themselves behave reliably and cannot be easily manipulated. So, let's look at the twin concerns of safety and security. Safety and security ensure that AI systems function reliably and remain resilient to threats. Without them, AI could cause unintended harm or be manipulated by malicious actors. Safety means confirming that an AI system performs as intended and avoids unexpected consequences. This requires extensive testing, validation under different conditions, and continuous monitoring in real-world settings. For example, self-driving vehicles must be tested in varied traffic and weather scenarios to ensure they perform reliably. Security, on the other hand, is about protection against attacks. AI introduces unique vulnerabilities such as data poisoning, where corrupted data skews outcomes, or adversarial examples, where small manipulations trick a model into making mistakes. Models need to be deployed in secure environments to prevent tampering, kept up to date so new that vulnerabilities aren't left open, and actively monitored to catch attacks as they happen. Each of these defenses addresses a different way an AI system could be exploited, making the overall system more resilient. Governance frameworks also recommend proactive measures like red teaming, where experts deliberately stress test AI systems, and incident response plans tailored specifically to AI. The aim is to improve overall safety and security, while also providing assurance to both stakeholders and regulators. Safety and security are governance responsibilities that ensure AI benefits society without putting people or organizations at risk. Now, even reliable, secure systems still need people in the loop, so let's take a look at human oversight. This is a good time to address a potential pitfall with complex AI. AI is not meant to replace human judgment. In fact, as we'll cover, AI needs human judgment to function effectively as well as ethically. AI systems have begun to take on increasingly complex roles. As they do, it's important that we keep humans as part of the decision-making process, especially when outcomes have ethical, legal, or social consequences. Human oversight can take different forms depending on the level of risk. In lower-risk systems, occasional checks may suffice. But in higher-risk areas like medical diagnoses or financial services, humans must actively supervise decisions to prevent harm. The key is to tailor human involvement to the potential impact of the AI system. We can think of oversight as a spectrum. Human in the loop. Human in the loop means people approve or validate AI decisions before they are finalized. Human on the loop. Here, people supervise an AI system and can intervene if it starts to behave unexpectedly. Human in command. With human in command, people retain ultimate control and decision-making authority. This makes sure accountability remains completely in human hands. However, oversight is only effective when humans can understand and influence AI's decisions. This means equipping people with the knowledge to interpret AI behavior and the authority to act when things go wrong. When oversight is properly managed, it allows humans to prevent harm by stepping in before errors or unfair outcomes happen. Human oversight keeps decisions grounded in real-world values. Machines may optimize for efficiency, but it's humans that consider fairness, compassion, and cultural context. By involving humans in important decisions, it keeps AI systems accountable and allows them to be both technically effective and trustworthy. So far, we've focused on principles that reduce risks: fairness, privacy, safety, and oversight. But governance is also about ensuring AI contributes to the world in a positive way. This brings us to our final principle: sustainability and societal benefit. Just as fairness, privacy, and oversight guide how AI should operate, sustainability and societal benefit guide why it should operate. AI governance should be about promoting positive outcomes for people and society. Sustainability asks us to think about the broader impacts of AI, from environmental footprint to social inclusion. Training large-scale models can consume enormous amounts of energy, And without mindful design, AI could worsen inequalities or harm vulnerable communities. Governance encourages anticipating these effects and taking steps to minimize negative consequences, like using energy-efficient infrastructure or consulting with diverse groups during the design phase. Societal benefit focuses on ensuring that AI serves everyone rather than a select few. Achieving this requires understanding the diverse needs and experiences of the people affected by AI systems. For instance, a model designed without considering marginalized communities may inadvertently exclude them or produce biased outcomes against them. By thoughtfully designing systems with these perspectives in mind, AI can better uphold human rights and respect cultural differences. When AI decisions reinforce fairness, inclusivity, and human-centered values, the technology supports social trust instead of undermining it. UNESCO's ethics recommendations and the OECD AI Principles illustrate how ethical alignment can be implemented, aiming to guide organizations into thinking beyond efficiency and instead towards the broader societal impacts of their AI systems. When sustainability is part of the work, AI stops being just tech and becomes something that clearly affects communities and the environment. This perspective helps us anticipate unintended consequences, design more inclusive systems, and judge whether AI is delivering value that aligns with broader social and environmental responsibilities. AI systems are never finished products. They change over time and unfortunately not always for the better. As data shifts, user behavior evolves, or new threats appear, an AI system that once performed well can begin to drift. That's why governance must include continuous monitoring and improvement, principles that keep systems reliable, fair, and aligned with expectations throughout their life cycle. This might sound straightforward, but monitoring starts with knowing what to look for. Organizations track performance on measures like accuracy, fairness, or safety, and they define in advance what would signal a problem. For example, if a model used in recruitment begins producing results that exclude certain groups, monitoring allows us to detect the change before it becomes systemic and causes harm. Improvement builds directly on top of monitoring. Once we've identified problems, we have to learn from them and adapt to avoid them in the future. If we look at a fraud detection system, it must constantly evolve as criminals develop new techniques. Without regular updates, the model will slowly become less effective and more vulnerable. Retraining with new data and learning from past failures means the system can keep pace. For this to work, monitoring and improvement need to be organized and visible. Audits, reviews, and incident reports provide a record that shows what has been checked, what has been fixed, and what has been learned. This makes the process trustworthy for both regulators and the people that rely on the system. In practice, continuous monitoring and improvement keep governance moving. They help you spot drift early, learn from incidents, and fold those lessons back into how the system is built and run. Up to now, we've been talking about governance principles as overarching concepts, but these principles only matter if they're put into practice. So, let's revisit accountability and see how organizations actually embed this principle into the way they work. It begins with leadership. In our first course, we introduced the idea that AI responsibility can't sit only with the technical teams. Leaders set the tone. If executives and boards treat accountability as optional, then any policies or processes risk becoming box-ticking exercises. But when leaders make themselves answerable for how AI is used, accountability becomes part of the culture rather than an empty statement. From there, responsibilities need to be clear. In practice, this means defining who does what across the AI lifecycle. For example, a data scientist may handle model development, a compliance officer may check regulatory alignment, and senior managers may be kept informed of major risks. The exact titles don't matter as much as the clarity. Everyone should know where responsibility begins and ends. Without this clarity, accountability quickly dissolves into finger-pointing. Documentation also plays a major role in this process. Records like testing procedures, decision logs, or impact assessments create a trail that can be reviewed if something goes wrong. When you can show why choices were made and who made them, accountability becomes visible and works to build consumer trust, whilst showing regulators your compliance efforts. Training is just as important. If staff don't know their responsibilities or don't have the confidence to act on them, then accountability can fall by the wayside. Training ensures that everyone from developers all the way up to senior leadership and decision makers understands their obligations and, more importantly, why those obligations matter. Finally, accountability must be supported by pathways for action. When problems arise, there needs to be a clear process for escalation and remediation. By giving people both the authority and the means to act, organizations make accountability a real, practical effort. The key takeaway here is that accountability should feel like a living practice that's organically built into leadership roles, documentation, training, and response. When applied in this way, accountability ensures that AI outcomes are linked to real people, real responsibilities, and real consequences. Let's move on to transparency. We already introduced transparency as openness, documenting how a system is built and explaining its decisions in ways people can understand. Now let's go a step further and look at how organizations can put this into practice day to day. Transparency works best when it's embedded as part of the workflow itself. That means building documentation into the development process rather than thinking of it as paperwork to fill in later. For example, recording the purpose of a model, its training data, and its known limitations should be just as routine as running code tests. This is often referred to as documentation by design and allows transparency to grow naturally from the way teams already work. It also matters how information is shared. As we touched on earlier, not everyone needs the same level of detail, and too much information can be just as unhelpful as too little. Governance frameworks address this by recommending a tiered approach to transparency. Of course, there are challenges. Being open can clash with other pressures like protecting intellectual property or guarding against security risks. A thoughtful approach means finding the right balance. Enough openness to build trust without exposing sensitive details that could be misused. As with monitoring and improvement, transparency is sustained by culture. Teams need to feel encouraged when raising concerns or identifying risks. When openness is treated as a strength, it's easier to spot problems early and maintain trust across teams. Embedding transparency into workflows, communication, and culture ensures that AI systems remain understandable, accountable, and worthy of trust. In our previous look at fairness, we explored why bias matters and how it can emerge in AI systems. Now let's look at how fairness can be put into practice so that AI systems can truly serve people equitably. Fairness is something you have to work on every step of the way. Declaring that your system is fair without doing the work isn't a shortcut to compliance. Think back to transparency. Just as documenting decisions helps others understand AI systems, actively checking for bias helps ensure those decisions don't disadvantage anyone. The first step is noticing where bias might appear. This can be subtle. Maybe certain groups are underrepresented in training data, labels are inconsistent, or algorithm choices unintentionally favor one outcome over another. Teams can spot these patterns through careful analysis, such as comparing how the system performs across different groups. For example, a recruitment tool may seem effective overall, but closer examination could reveal it systematically favors certain genders or age ranges. Early detection allows organizations to make adjustments before the bias affects real people. Mitigation naturally follows. If we detect gaps, we can rebalance data, refine models, or adjust thresholds so that decisions are fairer. This must be an ongoing process. Just like monitoring ensures reliability and safety, ongoing evaluation is necessary because real-world use can reveal new biases that weren't visible during testing. Equally important is bringing diverse perspectives into the process. Including people from different backgrounds helps catch blind spots that a less diverse team might miss. Collaboration across departments, combined with input from affected communities, strengthens the fairness of the system. Finally, fairness involves making difficult trade-offs visible. Sometimes improving equity in one area may affect performance in another. Clear documentation of these decisions shows how ethical and legal considerations were balanced, reinforcing accountability and trust. When fairness is properly applied and kept front and center, it becomes part of the system's DNA. It works to effectively reduce harm, but also ensure that AI supports human rights and societal values in meaningful, measurable ways. We've already seen the principles of privacy and data governance, consent, minimization, and secure handling of personal information. Unfortunately, this is rarely straightforward in practice. AI systems need data to work. But too much data or data that's messy or sensitive can create problems for both people and organizations. Teams have to constantly make trade-offs. For example, a fitness app might need activity data to give useful health recommendations, but collecting location history could invade privacy. Effective governance is about making these trade-offs in a thoughtful way. There are several practical approaches teams use. Anonymization and pseudonymization. This works by removing or masking any identifying details in data. This protects people's privacy, but it can make some data less useful for analysis. Differential privacy. This technique adds a little noise to datasets so that individual contributions aren't exposed. Models can still learn overall patterns safely. Synthetic or federated learning. Instead of centralizing real data, these methods create artificial datasets or train models on devices without moving sensitive data around. Even with these tools, privacy doesn't happen automatically. Teams need to decide which techniques to apply when to audit data and how to balance risk, utility, and compliance. Writing down decisions and the reasoning behind them makes practices reviewable and improvable. Privacy also evolves over time. New users, changing regulations, or emerging threats can change risks. Teams need to be aware of these changes, testing scenarios, reviewing logs, and adjusting practices so small problems don't grow into bigger ones. In practice, privacy and data governance are about making thoughtful choices every day. It's about using the right tools, checking assumptions, and staying alert to changes, the same way we've seen with accountability and fairness. When teams engage with it this way, privacy becomes part of the system itself, protecting people while helping everyone trust AI tools. Earlier, we explored the main security risks that AI systems face. Now let's see what this looks like in real-world systems and how teams handle these challenges day to day. AI systems are powerful, but that power can introduce new and unique risks. Anything from small mistakes to deliberate attacks can cause serious problems. Understanding these risks helps teams prevent them before they affect real people. A big challenge comes from data itself. AI learns from what it sees. If the data is tampered with, whether that's intentionally, like an attacker slipping in misleading examples, or if that's accidental, like poor quality records, the system can behave in unexpected ways. As an example, a spam filter might start letting phishing emails through because the training data was subtly changed. Checking for anomalies, testing data regularly, and keeping clear records of where data comes from are practical ways to reduce these kinds of risks. AI can also be tricked by inputs that look normal but produce the wrong outcome. Even a small, practically invisible change to a training image could result in a self-driving car misreading a stop sign. Teams manage this risk by testing models against unusual or tricky scenarios and adjusting their systems to handle surprises safely. AI systems often hold sensitive information. Clever analysis of a model could reveal private data. Protecting it requires both technical measures like encryption or safe training methods, and careful decisions about who can access models and how they are shared. Keeping AI systems safe and secure depends as much on people as it does technology. Teams need to notice signs of trouble early, respond quickly, and document what they learn. Roles, practices, and checks make it easier to act before problems grow. Threats change, vulnerabilities appear, and systems interact with new users and environments. Monitoring, testing, and learning from incidents are part of the ongoing process of keeping AI safe and secure. Earlier in the course, we introduced the 3 models of oversight: human in the loop, human on the loop, and human in command. Now let's take a closer look at how these approaches actually play out, and why choosing the right one isn't always simple. In high-stakes situations, human in the loop means a person reviews and confirms every decision before it takes effect. Think of a loan officer reviewing an AI's credit approval. This model offers strong protection against harm, but it comes at a cost. If every action requires human approval, systems can slow down dramatically and decision fatigue can set in. The safeguard itself is strong, but it can only work effectively if people have the time and resources to use it well. Human on the loop is more about ongoing supervision than individual checks. Instead of checking every decision, people watch the system's behavior and step in if something looks off. For example, a technician might supervise industrial robots and intervene if they begin acting in unsafe ways. The challenge is keeping humans engaged. If the oversight is too passive, problems might go unnoticed until it's too late. Human in command pulls back even further, focusing on the system as a whole. Here, people set boundaries rather than managing individual outputs. This means outlining what the AI is allowed to do, when it should stop, and what its intended goals are. This model is especially important in areas like government and law enforcement, where the public expects important decisions to be placed firmly in human hands. The broad scope of this approach is both its strength and its weakness. It allows for an AI system to be as efficient as possible within safe bounds, but if those boundaries aren't properly defined, it can lead to systems falling far out of alignment and becoming more of a problem than a solution. Each model has both strengths and weaknesses. Too much oversight can make systems slow or ineffective. Too little and risks can slip through unnoticed. The right balance depends on context, risk, and regulation. Our job is to find that balance. Let's now revisit sustainability and dig deeper into what that means in practice. AI has real potential to support climate goals, whether that's optimizing energy use in buildings, improving farming efficiency, or helping supply chains reduce waste. But running AI systems comes with costs of its own. Training and deploying large models can consume huge amounts of electricity, especially if data centers rely on non-renewable energy. Governance frameworks ask organizations to balance these benefits and costs, and to make those trade-offs transparent. One way to do this is by looking closely at efficiency. Do we really need a massive general-purpose model when a smaller, targeted one would do the job just as well? Techniques like pruning and quantization can slim models down, cutting their energy usage without losing out on accuracy. Choosing a domain-specific model can also mean less computing power, easier maintenance, and lower costs over time. It also means thinking about sustainability, which means looking at the full life cycle. Hardware wears out, software becomes outdated, and models need retraining. Responsible governance means preparing for those stages, extending the life of infrastructure, finding ways to update models without full retraining, and responsibly recycling or decommissioning equipment when it's no longer usable. Visibility is just as important here as in accountability or fairness. If an organization discloses the environmental impact of its AI systems, whether that's through audits, public reports, or by following voluntary standards, it makes the costs visible. That visibility builds trust and allows both regulators and the public to weigh in on whether those trade-offs are acceptable. In practice, sustainability is about making careful, informed choices at each stage, choices that show that AI's benefits are worth its costs, both for businesses and for the planet. So far, we've looked at how principles like accountability, fairness, and privacy show up in practice. But principles alone don't keep systems on track. Once an AI system is deployed, the real test is whether it stays reliable and responsible over time. That's where monitoring frameworks come in. A monitoring framework turns broad goals into practical realities. Instead of saying the model should be fair, teams decide what fairness looks like in numbers or thresholds, and set up alerts if performance slips. The same goes for accuracy, privacy, or any other principle. This makes it possible to spot problems early, rather than after they begin to cause harm. Good monitoring is a mix of automated tools that watch for issues, like data drift or unusual outputs, and people who can interpret what those signals actually mean. That balance matters. An alert only builds trust if someone with the right knowledge and expertise can explain it and decide what to do next. Monitoring also creates a record of responsibility. Logs of updates, incidents, and decisions form an audit trail that regulators, auditors, or even the public can review. These trails act as proof that governance is being treated as an ongoing process. Finally, frameworks like ISO IEC 42001 or the NIST AI Risk Management Framework highlight the importance of monitoring being adaptable. An AI system that works well today might behave differently as new data comes in, as people use it in unexpected ways, or as regulations change. A good monitoring framework sets rules that can be reviewed, updated, and improved whenever the need arises. This brings us to the next stage of the course. We've seen how principles play out in practice. Now we're going to look at how standards and frameworks formalize those practices, making governance consistent across both internal teams and industries. OECD AI Principles. The OECD AI Principles are one of the most widely used reference points for AI governance. Many later frameworks build on them, so understanding what they mean in practice is a great place to start. The principles are inclusive growth and well-being. This means AI should bring benefits that reach beyond a small group. For example, Optimizing public transport with AI improves the daily life for a whole city, instead of just a few corporate executives. Human-centered values and fairness. Systems should respect individuals' rights and avoid discrimination. In practice, this is where fairness testing and bias checks become important. Transparency and explainability. This means people need to know how AI systems reach their results and have a way to question them. This doesn't always mean showing code, but it does mean documenting decisions clearly. Robustness, security, and safety. AI has to be reliable in real-world conditions. That includes resisting attacks and performing consistently in critical areas like healthcare. Accountability. Someone needs to be responsible for AI's outcomes. That's why governance frameworks assign clear roles, like model owners or risk officers. As you can probably see, the OECD is a sort of backbone for effective AI governance. It covers many of the principles we've already looked at in this course. What matters here is less the list itself and more how it's used. These principles are often used as a baseline checklist, a starting point to compare organizational practices against. Because newer standards like the EU AI Act and ISO IEC 42001 echo the same ideas, being knowledgeable of the OECD principles gives you an advantage when it comes to aligning with new standards and regulations. UNESCO's Ethics Recommendation. UNESCO's Ethics Recommendation stands as a global ethics lens for AI. It's important because it highlights issues that often sit in the background into everyday design and decision-making. The recommendation covers human dignity and rights, which means AI should protect basic freedoms like privacy, equality, and freedom of expression. In practice, this means giving people clear ways to understand, question, and contest outcomes that affect them. Environmental sustainability. AI should minimize its footprint and support climate goals. This is linked to what we covered on sustainability. Choose right-sized models, disclose impacts, and plan for the full life cycle. Cultural diversity. AI must respect local context and avoid reinforcing stereotypes. Speech or vision models should be checked against dialects, names, and dress that reflect the communities they serve. Content rules should account for cultural nuance rather than copy-pasting a single policy globally. Inclusive and equitable benefit. This means AI should serve everyone, not just the most visible users. That means testing for who is left out and adjusting data and design so they are properly represented. Great examples of this are older adults in a health app or low connectivity users in a public service. As with the OECD, the value of UNESCO's recommendation is in how you use it. Think of it like a lens you hold up to your work. Before launching, pause and think. Whose norms are reflected here, who's missing, and what would harm look like in this context? If you can, invite a few voices from the communities affected and give an independent reviewer the authority to slow things down if concerns aren't resolved. It also helps to give basic ethics training across teams so that everyone is speaking the same language. Used alongside the OECD principles, UNESCO keeps culture, dignity, inclusion, and environmental impact in view. It doesn't replace technical checks, it just rounds them out. Using these tools properly means choices you can explain, and decisions you can stand behind in different places and contexts. The European Union Artificial Intelligence Act. We've already introduced the EU AI Act earlier in the course. Rather than listing risk categories, let's look at how it shows up in day-to-day work. The EU AI Act draws a simple line between people who build AI and people who use it. If you build or place an AI system on the European market, you're expected to design with governance in mind. Think through risks before release, document how the system works and what data it relies on, make space for human oversight, and keep records. If you use AI in your own operations, the expectations are different. Use it as intended, train the people who rely on it, keep the right logs, watch performance, and step in when something looks off. We've met all these ideas already in accountability, transparency, and monitoring. They're just becoming legal expectations in this context. Risk level sets how much evidence you need. Some uses are banned altogether. Others count as high risk. For example, decisions about jobs, education, or access to essential services. For high-risk uses, the bar is higher. Clearer documentation, a defined path for oversight, and checks that continue after launch. Lower-risk uses still benefit from the same habits, just with a lighter touch. There's one practical note worth mentioning. If you take a model and change what it's used for For example, you adapt a vendor's tool and use it in a new decision that affects people, you can slide from user toward builder, and the duties shift with you. Version control, change logs, and a plain English statement of intent can help you avoid that. After launch, the Act expects systems to be watched in the real world. That fits the monitoring approach we've been building. Decide what good looks like, look out for when things drift, act early, and record what you did. If something serious happens, then you're expected to report them. The groundwork you laid earlier, roles, logs, incident playbooks, will make that more manageable. To effectively work within the EU AI Act, you need 3 things we've already covered in this course. Be clear about your role, be honest about the risk of the use case, and keep evidence of how your governance works in practice. That's what regulators will be looking for. The ISO IEC 42001 standard. We've already mentioned ISO 42001 before, so rather than define it again, let's look at how it applies to a day-to-day context. If the EU AI Act sets the legal bar, ISO 42001 gives you a practical way to reach that bar. Think of it as an amalgamation of the habits we've been building: accountability, fairness, privacy, safety, and monitoring, brought together as something called an AI management system, or AIMS. In practice, an AIMS starts with scope and purpose. You decide which AI systems are covered, why they exist, and who is responsible for them. Write that down in plain language. Keep an inventory of models and datasets with named owners. Link each use case to a simple risk register and an oversight path so it's clear who gets involved and when. ISO 42001 runs as a loop rather than a one-off. You plan the controls that fit the risk. You build and operate to those controls. You check what actually happened through monitoring, audits, and incident reviews, and then you adjust based on what you learned. It's the same rhythm we've used already for accountability and continuous monitoring, just made explicit and repeatable. 2 ideas matter here. First, proportionality. Not every system needs the same weight of governance. A low-impact assistant can run on lighter checks. A hiring model or anything safety-critical needs tighter ones. Second, evidence. Policies, training records, test results, approvals, monitoring snapshots, and post-incident notes show that your process is real and not just for show. If you're already experienced with something like ISO 27001 or ISO 9001, then ISO 42001 will feel familiar. You can reuse the structure you have: management reviews, corrective actions, supplier oversight, and plug AI-specific pieces into it, such as model inventories, bias testing, and human oversight steps. To get the most out of ISO 42001, be clear about what's being covered, match your controls to the risk, and keep the proof fresh. The NIST AI Risk Management Framework. The NIST AI Risk Management Framework sits neatly inside the loop that ISO 42001 provides. It doesn't set laws. It gives you a practical way to think through risk as you plan, build, test, ship, and maintain an AI system. NIST breaks the work into 4 habits you can keep returning to whenever you need them: govern, map, measure, and manage. Let's explore them now. Start with govern. This is the scaffolding, the roles, policies, and routines that make risk work visible. In practice, that means naming owners for each model, keeping a short, plain English policy for how AI is used, and making sure incident playbooks and escalation paths are known before anything goes live. It runs on the same steps of accountability that we've covered throughout this course: clear responsibility, documented decisions, and room for human oversight. Map is about context. Before you train or deploy your AI, write down what the system is for, who it affects, where it could cause harm, and how it might be misused. A 1-page statement of intent, a quick context diagram, and a list of affected groups will do more for risk than a dozen slide decks. This is also where you flag sensitive data, constraints from laws or policies, and any assumptions the system depends on. Measure turns those assumptions into checks. Build small evaluation sets that reflect real use. Track basic performance, but also fairness, robustness to odd inputs, and privacy risks wherever relevant. If you're using explainability techniques like the LIME and SHAP tools we discussed earlier, make a note of what they show and where they fall short. We're aiming for an honest picture that you can act on, not top marks. Manage is what you do with that picture. Put risks in a simple register. Decide what gets fixed now and what needs deeper work. Assign owners and set thresholds that trigger action after launch. This is also where we apply monitoring techniques. Define what healthy looks like, watch for drift, and keep a short record of updates, incidents, and what you learned. When something goes wrong, the same loop applies. Capture it, fix it, and fold the lesson back into govern and map. If ISO 42001 gives you the operating system for AI management, then NIST gives you the day-to-day guidance for risk. When used together, they keep you organized and honest. Clear scope, clear roles, real-world checks, and adjustments you can show if you're asked how your AI is being governed. Now that we've covered the principles and looked at the frameworks and standards we'll be working alongside, let's see how they come together in a real-world scenario. Imagine a team introducing an AI-assisted screening tool that helps route job applications to the right reviewer. We start by writing one sentence of intent: what the tool does, who it serves, and what decisions it will never be allowed to make on its own. That sentence is the anchor for everything else. Next, we make responsibility visible. One person owns the model, one owns the data, and one owns risk. Their names go on the page so that questions have a place to go. Then oversight. For routine cases, the tool can suggest a route. For less common cases, a human approves decisions before anything moves forward. This is written into the workflow, not left to habit. Before launch, we test with our own data, not just a demo set. We check accuracy and look for fairness gaps that matter in this context. If we find one, we adjust by rebalancing data and tweaking thresholds, then we keep a note of what we changed and why. We also decide what we're willing to explain. A short, plain English summary tells people which factors influenced a result and how to request a review. The full technical detail lives in the documentation for auditors and engineers. After going live, we watch a small set of signals. Performance on real cases, any widening gaps between groups, unusual spikes and errors, and how often humans override the AI. Something drifts, we act early and record what we did. Finally, we keep a small folder of evidence. The intent statement, the data sources, test results, the explanation template, and the incident playbook. Nothing fancy, just enough to show how decisions were made and who made them. That's the same pattern you've seen throughout this course. Be clear about purpose, make roles explicit, choose an oversight model that fits the risk, test for the harms that matter here, explain what you can, and keep watching after launch. Now that we've reached the conclusion of the course, we've covered the ground you need to start working with AI in a responsible way. You've seen how the principles fit together: accountability, transparency, fairness, privacy, safety, human oversight, sustainability, and ongoing monitoring, and how they show up in everyday decisions. You've also met the frameworks you'll work alongside in practice: the OECD and UNESCO guidance, the EU AI Act, the ISO IEC 42001 standard, and the NIST Artificial Intelligence Risk Management Framework. When you take this back to your own work, return to the simple pattern we've used throughout. Begin with a one-sentence intent for any AI tool. Make roles visible so questions have a place to go. Choose an oversight approach that fits the risk. Test for the harm that matters in your context. Explain what you reasonably can and stay vigilant after launch. That loop, decide, document, check, adjust, is governance at work. If you want a quick exercise to put this into practice, pick one AI system and try 3 small steps. Write the intent sentence, name who owns the model, data, and risk, and choose 2 signals you'll monitor after deployment. Keep those notes together. They'll become the start of your evidence and your improvement plan. If any concepts feel new, you can revisit the earlier parts of this course, or go back to our first course, AI Governance Fundamentals, for a broader walkthrough of the basics, before returning here. We'd like to thank you for your time, and we hope this course has been helpful in your journey into AI governance. Feel free to check out more of our resources or keep up to date with our blogs at safeshield.cloud.